We remember D-Day for the beaches and the bullets, but the real victory was won months earlier, in a war fought with invisible waves and magnetic fields, a war the Nazis thought they'd already won. What if the most devastating weapon of World War II wasn't a bomb, but a simple strip of aluminum foil? The Nazis invented it first, and then, in an act of fatal arrogance, they banned it. In 1939, German mines were sinking ships without ever touching them. Yet by 1944, Allied bombers flew over Germany untouched. How the Allies solved these two different invisible threats is the story of how the war was truly won. We remember D-Day for the beaches, the boats, and the bullets. We see the grainy, black and white footage, the sheer courage of brave men storming the sand under a hail of fire. It's etched into our minds as the day the tide turned. But the real victory, the one that allowed D-Day to even happen, was won months, even years earlier. It wasn't fought with tanks or bayonets. It was fought in quiet, cluttered laboratories in Britain and in the halls of MIT. It was a war of invisible waves, of silent magnetic fields, and of faint radio signals crackling in a headset. And it was a war the Nazis, in their hubris, thought they had already won. Their fatal mistake wasn't just underestimating the industrial power of America, though they certainly did that. Their greatest failure was dismissing the quiet, relentless, and often desperate ingenuity of Allied scientists. Men and women who, when faced with an unbeatable weapon, simply sat down, had a cup of tea, and got to work figuring out how to beat it. The Nazis possessed a technological brilliance that gave them an early, terrifying edge, but that brilliance was coupled with a fatal arrogance. They believed their science was supreme and their enemies were inferior. And so they dismissed the threats, they dismissed the counters, and in one case, they even dismissed their own best invention. This is the story of two of the greatest invisible battles of the Second World War. It's a story that's often overlooked, but it is the key to understanding how the war was truly won. It's the story of the fight against the magnetic mine and the devastating war of the airwaves. It starts not with the scream of a Stuka dive bomber, but with a deafening underwater explosion in the cold, dark waters of the Thames estuary. The year is 1939. The war is just weeks old. Britain has declared war, but most of the fighting is far away, in Poland. A nervous quiet, what they called the phony war, has settled over the home front. But in the shipping lanes, it is anything but phony. British ships, merchant vessels carrying the food and iron ore that were Britain's very bloodline, are exploding. One after another, they vanish from the seas. But there's a horrifying mystery. They're not being hit by torpedoes from U-boats. Their lookouts see no periscopes, no bubbles in the water. They're not striking other ships. They are blowing up in open water in channels that had been swept for mines just hours before. The panic in the Admiralty was immediate and profound. This was a new weapon, a secret weapon, the kind that haunted the nightmares of the High Command. It was a mine that didn't need a ship to hit it. It could feel the ship passing overhead. The Germans, with their typical cold efficiency, had unleashed the magnet mine, the magnetic mine.
This was terror, pure and simple. It was designed not just to sink ships, but to strangle a nation. Britain is an island. Then, as now, it imported almost everything. Its food, its fuel, its raw materials. Without the constant flow of merchant shipping, Britain would starve. It would freeze. Its factories would grind to a halt. The Royal Navy, the most powerful fleet in the world, was suddenly helpless. Its dominance of the seas was rendered meaningless by a weapon lying silent on the seabed. And the Germans knew it. They sowed these mines by the hundreds, dropped by seaplanes under the cover of night into the mouths of rivers, harbors, and vital shipping channels. The existing British minesweepers were useless. Those sweepers were designed to deal with the mines of the First World War. Those were simple, floating iron balls tethered to an anchor. A minesweeper would drag a heavy cable, called a sweep, through the water. The cable would snag the mine's tether, pull it, and a cutter on the cable would snap it. The mine would then bob to the surface, and the crew would destroy it with rifle fire. It was a straightforward, mechanical process. But these new German mines were different. They weren't floating. They lay on the bottom, in the mud, completely hidden. And they weren't triggered by contact. They were triggered by a fundamental force of nature. Every large ship made of steel, which is to say every military and merchant ship, has a magnetic signature. As it's built, the thousands of tons of steel in its hull become slightly but measurably magnetized by the Earth's own magnetic field. When that massive metal ship sails through the water, it carries that magnetic field with it. The German mine contained a device called a magnetic galvanometer, a needle balanced with exquisite sensitivity. When a ship passed overhead, its magnetic field would disturb the Earth's natural field just enough to tip that needle, close an electrical circuit, and detonate 660 pounds of high explosives. The Nazis were sinking a dozen ships a week. At this rate, Britain would be starved into submission before America could even think about joining the fight. Churchill himself, as First Lord of the Admiralty, was getting the daily frantic reports. He demanded an answer. But how do you stop a ghost? How do you fight magnetism itself? The British needed a miracle. They needed one of these mines intact. And that miracle came, as they so often do, not from a grand plan, but from pure chance, foul weather, and incredible bravery. On the night of November 23, 1939, a Heinkel HE-111 bomber was flying low over the Thames estuary, dropping its cargo of mines by parachute. The pilot misjudged his altitude in the bad weather. One of his mines didn't plunge into the deep water channel. It dropped onto a vast, slick mudflat at Shoeburyness, at low tide, and it was intact. A coastal watcher spotted the parachute descending and heard the splash. At dawn, they saw it. A large metal cylinder, half buried in the mud, its parachute silk pooled around it. The call went out. This was their chance. A team of specialists, led by a quiet, pipe-smoking man, Lieutenant Commander John Alvary, was dispatched from the Navy's Mine Warfare School. They were joined by a scientific expert, Lieutenant Commander Roger Lewis. They knew what it was, and they knew it was likely booby-trapped. They knew it was magnetically sensitive. The slightest piece of iron, a belt buckle, a steel helmet, even the steel shanks in their military boots could be enough to set it off, killing them and destroying the prize. So they stripped off anything metal. They commissioned special non-magnetic brass tools to be made overnight. They put on rubber diving suits, not for the water, but for the freezing, waist-deep mud. And as the tide receded, they began the long, lonely walk out onto that mudflat. Imagine the tension, working in the biting November wind, in the mud, with a weapon no one in the world understood. Every tick of their tools on the metal casing was a gamble. The mine was German. It was almost certainly designed to kill anyone who tried to do exactly what they were doing. They had to assume it had anti-handling devices. A trigger that would fire if it was tilted, a trigger that would fire if the light hit it, a trigger that would fire if its outer casing was breached. Alvary and his team worked for hours. They carefully, methodically took measurements. They sketched it. They photographed it. They identified the access plates. With their brass wrenches, they began to turn the first screws. Every man there knew that his life depended on the cold, calculating mind of a German he had never met. They found the first detonator. Carefully, they traced its wires. They found the arming mechanism. They found the primary trigger. If you find these hidden stories of ingenuity as fascinating as I do, and believe me, we have a lot of them, consider subscribing to the channel. We make it our mission to dig these up because they deserve to be told, and they shouldn't be forgotten.
Slowly, painstakingly, they neutralized it. They found the main explosive charge. And then, deep inside, they found the secret, the magnetic trigger, the little balanced needle. They had done it. They had defused mine number 1. It was towed ashore, loaded onto a truck, and rushed to the Admiralty's research facility, HMS Vernon. The scientists, who had been waiting in agony, fell upon it. They worked around the clock, taking it apart, testing every component. Now they had the enemy's playbook. They had the mechanism. And the problem was passed to a Canadian physicist working for the British Admiralty, a brilliant, practical man named Charles F. Goodeve, a name we should all remember, though few of us do.
Goodeve and his team looked at the trigger sensitivity. They confirmed it was reacting to the ship's magnetism. The solution, they realized, couldn't be to just sweep for these mines. You'd never find them all. The solution had to be to make the ships invisible to them. If the mine was looking for a ship's magnetic signature, the answer was to erase that signature. But how do you erase the magnetism of a 10,000-ton steel battleship? You can't just wave a magnet over it. Or could you? This is where the genius came in. The answer was called de-Gaussing. A Gauss is a unit of magnetism. De-Gaussing is simply the process of removing it. Goodeve's team figured out that if you ran a belt of electrical cable around the outside of the ship's hull and passed a specific, carefully calculated electrical current through it, you could create an opposing magnetic field. This new field, generated by the wire, would perfectly cancel out the ship's own natural magnetism. To the sensitive mine lying on the seabed, the ship simply vanished. It passed over like a wooden raft, silent and magnetically invisible. This was brilliant, a breakthrough of the highest order. It was a perfect, elegant solution from the world of physics applied to the brutal reality of war. But now came the real problem. This wasn't a laboratory. This was a war. They didn't need to de-Gauss one ship in a test tank. They needed to de-Gauss every single ship in the Royal Navy, every merchant vessel bringing food from America, every troop transport, thousands and thousands of them, and they needed to do it immediately. This is where the story shifts from pure science to a story of logistics and industrial might, a story that would define the Allied victory. The British, in their desperation, developed two methods. The first, a quick fix, was called wiping. It was exactly what it sounds like. They would wrap a ship from bow to stern in massive, heavy-duty electrical cables. Then they'd blast it with a powerful jolt of electricity, essentially wiping its magnetic memory clean, scrambling its signature. This worked. It got ships out of the harbor, but it was temporary. A ship's magnetism is not static. As it sails, as it pitches and rolls in the heavy Atlantic seas, as it simply travels north and south across the globe, the Earth's magnetic field slowly, steadily remagnetizes the whole. A wiped ship would be safe for a few weeks, but then it would become dangerous again. It needed a constant, active solution. This led to the second, more permanent fix, installing the de-Gaussing coils or girdles directly onto the ships. This was an enormous undertaking. It meant fitting miles of heavy insulated copper cable to the outside of the hulls of thousands of ships. It meant installing complex generators to power them and delicate controls on the bridge so the ship's crew could adjust to the current based on their latitude. This required copper, tons and tons of copper. It required skilled electricians. It required shipyard space. All of these were in desperately short supply in a Britain fighting for its life. But they did it. They commandeered every piece of copper cable in the country. They worked day and night. Pictures from 1940 show these thick black cables wrapped around the hulls of proud destroyers and even the Queen Elizabeth, giving them a strange girdled look. And that's where the American industrial might that the Nazis so often dismissed as crude and unsophisticated began to enter the picture. As the Lend-Lease Act kicked in and America became the arsenal of democracy, this technology was transferred. U.S. naval yards from Brooklyn to Pearl Harbor, Norfolk to San Diego began installing these systems at a breathtaking rate. They didn't just copy the British design, they improved it, standardized it. They set up de-Gaussing stations. These were ranges, often at the mouth of a harbor, where a newly fitted ship would sail over a grid of underwater magnetic sensors. Scientists on shore would measure its signature, then radio up the precise settings for its coil. The ship's de-Gaussing officer would dial it in and the ship would pass over again and again until its signature was flat, until it was invisible. The Nazis' wonder weapon, the mine that was supposed to win the war in 6 months, was neutered. It was neutered by the bravery of John Overy on a mudflat, the genius of Charles Goodeve in a lab, and the combined industrial will of Britain and America. And the Germans? They were slow to react. They assumed their mine was unbeatable. They couldn't believe the British could have solved it so quickly. By the time they realized what the Allies were doing, the tide had turned.
They tried to counter, of course. They developed acoustic mines triggered by the sound of a ship's propellers, and the Allies developed counters for those too, loud noisemakers towed behind the ship. They developed pressure mines triggered by the change in water pressure as a ship passed over. Those were the deadliest of all, and many remained a threat long after the war. But the magnetic mine, the one that caused the initial panic, was finished as a war-winning weapon. The invisible magnetic shield, born from a mudflat in Shoebury-Ness, had saved Britain. But this was only the first invisible war. The second was about to begin high in the black, freezing night skies over Germany. Now we move to 1940, the Battle of Britain. The Luftwaffe is pounding London in the Blitz. Their goal is to break the will of the British people. But they have a problem. Flying in the daytime means facing the RAF's Spitfires and Hurricanes, and that's proving too costly. So, they shift to night bombing. But night bombing in 1940 is almost useless. Imagine flying a Henkel bomber in total pitching blackness with no GPS, no satellites, just a map on your knee and a compass. You're trying to find a specific target, a factory, a rail yard, a power station that is blacked out, hidden in a sea of darkness. It was like trying to find a needle in a haystack that was miles wide. Most bombs fell harmlessly in fields or on residential areas, which was tragic, but it wasn't militarily effective.
Yet somehow, some German bombers were hitting their targets with unnerving surgical accuracy. Bombs were landing directly on vital aircraft factories in Coventry. Key rail yards were being hit night after night. Fires were starting exactly where they would cause the most damage. It was too precise to be luck. The British were convinced the Germans had a secret. They were right. The Nazis, who were masters of radio technology, had developed a system the British would come to call Knickebein, or crooked leg. It was deceptively simple, but absolutely brilliant. The Germans set up two powerful radio transmitters in occupied France. Each transmitter sent out a very narrow, very precise radio beam, like an invisible lighthouse beam. One beam was a stream of Morse code dots. The other was a stream of Morse code dashes. The beams were aimed so that they would cross directly over the target in England. A German bomber would fly from France and find the dot beam. The pilot's headphones would be plugged into a special receiver. All he had to do was fly along that beam. If he drifted too far to one side, the dots would get weak. If he drifted to the other, they'd get weak. But if he stayed in the center, he'd hear a steady, strong dot, dot, dot. He would fly this invisible road all the way across the English Channel. As he got closer to the target, his radio operator would start to hear the dashes from the second beam, first faintly, then louder and louder. When the dots and the dashes merged, when the pilot heard one solid, continuous, screaming tone, he knew he was perfectly, exactly over the target. He didn't need to see a thing. He just opened the bomb bay doors and released his payload. This was a nightmare for the British. It was precision bombing at night, guided by an invisible road in the sky. It rendered the blackout useless. It meant no factory, no port, no airfield was safe. How could they possibly fight it? You can't shoot down a radio beam. This problem fell to one of the war's greatest unsung heroes, a young Scottish physicist named Reginald V. Jones. R.V. Jones was a brilliant, no-nonsense, and slightly eccentric scientist. He was just 28 years old, but he was in charge of a tiny new department called scientific intelligence. It was his job to figure out what the German scientists were up to. Jones got his hands on scraps of intelligence. He found notes from a captured German airman that mentioned headphones and hearing the target. He looked at decoded Enigma messages, which were just fragments. He began to piece together a theory. He suspected they were using radio beams. But the senior officers at the Air Ministry dismissed him. They were old-school military men. They were cavalry officers and fighter pilots from the last war. They thought this beam idea was outlandish, science fiction, too clever by half. They believed the Germans were just very, very good navigators. They thought Jones was a boffin, an egghead who didn't understand real war.
This is a classic case of what the title of our video is about, the dismissal of new technology. In this case, it was the British almost dismissing it to their own peril. But Jones was stubborn. He believed his data. He went straight to Churchill's scientific advisor, and he convinced him to authorize a special reconnaissance flight. A plane, a small Avro Anson, was fitted with a special radio receiver. It was flown by a trusted pilot, and Jones himself gave the pilot his flight path. He told him to fly back and forth across a specific part of England, listening for a signal on a frequency Jones had calculated. The air marshals thought it was a waste of time and fuel. The pilot went up, and sure enough, he found it, a crisp, clear radio beam coming from France, and it was aimed directly at the Rolls-Royce engine factory in Derby. This was the factory building the Merlin engines for every Spitfire and Hurricane. It was one of the most important targets in all of Britain. Jones had his proof. The Battle of the Beams, as Churchill would later call it, had begun. Now the question was how to stop it. They couldn't just block the signal with static. The Germans would know instantly that they'd been found out, and they would just change the frequency or change the whole system. They had to be clever. They had to be deceptive. This is the signal jamming from our video's title, and its first application was pure genius. Jones's idea was simple. Don't block the beam, he said. Just copy it. Or better yet, bend it. So the British, in a mad scramble, built their own radio transmitters. They codenamed them aspirin because they were the cure for the German headache. When the German dot beam was transmitting, the British aspirin transmitter would broadcast dots right on top of it, but slightly stronger. This just made the beam seem wider and easier to fly along. It fattened the beam. But the real genius was what they did to the dash beam. They built a transmitter that would broadcast dashes slightly off from the German signal. This had the effect of bending the dash beam. The German pilot, listening in his headphones, was still looking for that perfect, steady tone where the dots and dashes merged, but because the British were rebroadcasting the dash signal from a different location, that merge point was no longer over the factory. It was now several miles away, over an empty field.
The German pilot, confident in his technology, would follow his signal, that steady, reassuring tone. He'd hear it, beep, and he'd shout, Bomben los, bombs away. His bombs would fall, whistling down, and explode harmlessly, miles from anything important. The Germans were completely baffled. Their pilots would return from the mission, swearing they had hit the target, that the signal was perfect. But the reconnaissance photos the next day showed nothing, just craters in the mud. The British, with a brilliant bit of electronic judo, had used the Germans' own system to defeat them. They even started broadcasting their own false dot signals from random locations, creating dozens of false beams, scattering the German bombers all over the countryside, making them drop their bombs on Scottish mountains and Welsh valleys. The Germans' wonder weapon had been turned into a weapon of total confusion. Of course, the Germans didn't give up. This was an arms race. When they realized Knickerbein was compromised, they developed a more complex system called X-Gerät, X-apparatus. This used 4 beams, 1 to fly along, and 3 cross beams that would tell the pilot how far he was from the target. The first cross beam was a warning. The second was to open the bomb bay doors. The third was to release. And each time, R.V. Jones and his team figured it out. They analyzed the signals. They built jammers. For X-Gerät, they figured out which crossbeam was the bomb release beam, and they built a transmitter to broadcast that signal early. The German bombers would be 10 miles from their target, and suddenly they'd get the release signal. They'd drop their bombs and fly home. Mission accomplished. Another 50 tons of high explosives wasted. This back and forth, this invisible fight of signals, jammers, and counter-jammers was where the United States, as it entered the war, would truly make its mark. The U.S. had a nascent, but incredibly powerful electronics industry. The labs at MIT, Harvard, and Bell were filled with some of the brightest minds on the planet. When America joined the war, this Battle of the Beams became a full-scale industrial operation. The U.S. began mass-producing jammers, receivers, and most importantly, advanced radar sets. But this led to the next great invisible challenge.
The tables were turning, massively. By 1942, the offensive had shifted. It was no longer German bombers over London. It was American B-17 Flying Fortresses and B-24 Liberators by day, and British Lancasters and Halifaxes by night, flying deep into the heart of the Reich. But they were being slaughtered. The German Night Fighter Force, built by the brilliant General Josef Kammhuber, was the most sophisticated air defense system the world had ever seen. It was called the Kammhuber Line. It was a belt of radar stations, searchlights, and anti-aircraft guns that stretched from Denmark all the way to France. Here's how it worked. First, a long-range Freya radar would pick up the bomber stream as it formed up over England, hundreds of miles away. The Freya operator would alert the entire line. Achtung, 1000 Bomberstrom. The 1000 bomber stream is coming. Then, as the bombers got closer, they would enter a box, a sector of sky controlled by a single precise Würzburg radar. This Würzburg radar was a masterpiece of German engineering. It was a large parabolic dish, and it was deadly accurate. It would lock onto a single Allied bomber. That Würzburg radar would then do two things at once. It would paint the bomber for the heavy anti-aircraft guns on the ground, directing their fire. At the same time, it would guide a German night fighter, a Messerschmitt Bf-110, or a Junkers Ju-88, directly to the unsuspecting bomber. The German fighter, equipped with its own onboard Liechtenstein radar, could see the bomber in the dark. The Allied crews? They never even saw them coming. All they knew was that one moment, their tail gunner was scanning the empty dark. The next, cannon shells were ripping through the fuselage. The losses were catastrophic. On some raids, 10% of the bombers were lost in a single night. A crewman's chances of surviving a full tour of 30 missions were terrifyingly low. Many viewers have told us their fathers or grandfathers were part of these crews, and the sense of fatalism was overwhelming. They would go to the mess hall in the morning and see empty chairs at the tables of the men who had been playing cards with them just the night before. The Allies were in the exact same position the British had been in 1940. They were being hunted by an invisible enemy. They had to find a way to blind the German radar. But how? They didn't know the Würzburg's frequency. They didn't know its weaknesses. They needed to get their hands on one. This led to the most daring and, frankly, the most British commando raids of the war. Operation Biting, the Bruneval Raid. In February 1942, a small team of 120 British paratroopers, C Company of the 2nd Parachute Battalion, led by the dashing Major John Frost, was given an impossible mission. Their target? A single, lonely German radar dish perched on a cliff edge on Bruneval on the coast of occupied France. Their job was not to destroy it. It was to steal it. They were joined by a quiet, unassuming radar technician, a Flight Sergeant C.W.H. High. He was, in many ways, the most important man on the raid. He was the only one who knew what the vital parts looked like. The paratrooper's job was just to get him there and get him out. They dropped in the dead of night, in the snow. The landing was scattered, but they regrouped. They assaulted the small garrison guarding the radar. The fighting was brief and brutal at point-blank range. The paratroopers held off the guards while Cox, with bullets literally flying over his head, ran to the massive Würzburg dish. He had brought a toolkit of specialized wrenches, but in the chaos, he dropped his tools in the snow. He had to use his bare hands in the freezing cold to tear the components out.
He knew what he needed: the transmitter, the receiver, the pulse generator, the key guts of the machine. He ripped them out, wires sparking, and stuffed them into his bag. The team then fought their way down a narrow ravine to the beach, but the Royal Navy boats that were supposed to pick them up were nowhere to be seen. For a terrifying 20 minutes, they were trapped on the beach, with German reinforcements closing in. Finally, the boats arrived. They had been delayed by a naval skirmish offshore. The commandos piled in, carrying their wounded and their priceless cargo. They had brought the German radar home. Now, the scientists at the Telecommunications Research Establishment, the TRE, fell upon it. They laid it out on a laboratory bench. They took it apart, piece by piece.
They found its frequency, they found its strengths, and most importantly, they found its weakness. The Wurzburg was an excellent piece of engineering. It was too good. It was like a high-performance race car, finely tuned but delicate. It operated on a very narrow, specific band of frequencies. It could be fooled. The question was, with what? Jamming it with electronic noise like they did the Nicobine beams was one option, but that would take massive, powerful transmitters. These transmitters were heavy. They would have to be carried in the bombers themselves, taking up the space and weight of precious bombs. It wasn't efficient. They needed something simpler, something cheap, something every single one of the 1,000 bombers in a raid could carry. This is where we come to the most profound dismissal of the war, the one that the title of this video is all about. The Allies were struggling. They were testing all sorts of complex electronic jammers, but a woman named Joan Curran, a scientist working at the TRE, had a simple, brilliant idea. She wasn't a senior physicist, she was a junior researcher, and she remembered an old, obscure piece of research. She knew that if you dropped strips of metal, they would reflect radar signals. What if they just dropped clouds of it? Simple, aluminum foil strips. But, and this was the key, what if they were cut to a specific length? If the strips were cut to half the wavelength of the Wurzburg's radar beam, they would resonate. They would vibrate with the radar's energy and reflect it back perfectly. The idea was tested. They dropped bundles of these strips from a plane. On the radar screen below, the single, clean blip of the airplane instantly vanished. It was replaced by a massive, chaotic, swirling blip that looked like a whole squadron of planes. It was a perfect, impenetrable cloud of false signals. The British called it window. The Americans, who were developing the exact same idea at the same time at Harvard's Radio Research Laboratory, or RRL, called it chaff. It was, without a doubt, the single most important countermeasure of the air war. It cost pennies to make. It was just aluminum foil, the same stuff you have in your kitchen, backed with black paper so the German crews couldn't see it glistening in the moonlight, and cut into precise strips. But now came the catch, a terrible, paralyzing catch. The British High Command was terrified to use it. The moment they saw how well it worked, they realized the awful truth. If this simple trick worked so well against German radar, it would work just as well against their own radar. And Britain itself, especially the coast, was still vulnerable to German bombing. This led to a bitter, year-long debate that raged in the highest, most secret offices in London. The scientists, like R.V. Jones, were pleading with Churchill to use it. They argued it would save thousands of airmen's lives now. The losses over Germany were unsustainable. The military leaders, especially Air Marshal Trafford Leigh-Mallory, head of Fighter Command, were adamantly opposed. They were worried about the long-term consequences. What if the Germans copied it, which they could do in a single day, and used it to blind England's coastal defenses, allowing for a new blitz, or worse, a seaborne invasion? It was a terrible gamble. Save your own airmen today, or risk the defense of your entire country tomorrow. Churchill was torn. He waited, and he waited. The losses mounted. Finally, in the summer of 1943, the decision was made. The bomber offensive was critical. The losses had to be stopped. The target was Hamburg. The operation was codenamed Gomorrah. This would be the first time window was used on a massive scale. On the night of July 24, 1943, the bomber stream of over 700 aircraft went in. Every single plane was loaded with bundles of window. The crews, who had been sworn to secrecy, were instructed to drop one bundle every minute, pushing them out of a special chute in the floor. As the bombers crossed the German coast, the night sky filled with millions of tiny, fluttering strips of aluminum. The effect on the German air defense system was immediate and total. It completely collapsed. The Wurzburg radar operators, who were used to seeing a few, clean, trackable blips, were suddenly staring at a snowstorm. A solid, unreadable mass of white noise covered their screens. They couldn't tell the difference between a strip of foil and a 30-ton Lancaster bomber. The German night fighter crews were frantic. Their ground controllers were screaming at them, but they had no targets to give. The radar-guided searchlights swept wildly across the sky, finding nothing. The anti-aircraft guns on the ground, also guided by radar, were firing blindly into the night, hitting nothing. The entire Kamm-Huber line, That multi-billion Reichsmark system of defense was rendered deaf, dumb, and blind by kitchen foil. That night, Allied losses were shockingly low. Only 12 bombers were lost, most to random flak. The window had worked better than anyone's wildest dreams. The raid on Hamburg was one of the most devastating of the entire war, creating a firestorm that engulfed the city and killed over 40,000 people. It was a terrible, brutal night, and it was all made possible by simple strips of foil. But now we come to the real story, the ultimate irony, the dismissal that cost the Nazis the war in the air. Why were the Germans so completely, totally unprepared for window? They hadn't developed any filters for their radar. They had no counter tactics. They were caught completely flat-footed. Why? Because they had already invented it. That's right, a full year before the British, a German scientist named H.G. Klug had developed the exact same thing. He called it Duppel, named after the area near Berlin where he tested it. He demonstrated it to the German High Command, including Hermann Göring, the bombastic head of the Luftwaffe. He showed them how this simple, cheap foil could completely blind their own, brand new, expensive Wurzburg radars. And what was the Nazi response? Was it to immediately start developing countermeasures, filters, new radar types? No, it was panic. Hermann Göring was so terrified that the Allies might discover this simple cheap trick and use it against him that he ordered a total ban on all Duppel research. He classified it as top secret, not to protect it from the enemy, but to bury it from his own people. He forbid anyone from even mentioning it under penalty of death. He ordered all reports, all prototypes, all research be locked away or destroyed. This is the arrogance that defined their failure. Göring and Hitler himself believed so strongly in their own technological supremacy, so strongly in the offensive power of the Reich, that they refused to even consider a defensive weakness. They dismissed the idea that the Allies, the Americans and the British, could ever mount a bombing campaign serious enough for Duppel to be a threat against them. In their minds, they were the bombers. They were the attackers. Their arrogance made them blind. When window was finally used over Hamburg, the German leadership was stunned. General Josef Kammhuber, the man who built the Kammhuber line, said, "The war in the air was lost in a single night." When Göring was told, he reportedly flew into a rage not at the Allies, but at his own scientists, screaming at them, demanding to know why they hadn't invented a counter. And his scientists, terrified, had to remind him, "We did invent this a year ago. You ordered us to stop." That single act of dismissal, that decision born from pure hubris, cost them everything. They had the key to the next chapter of the war, and they locked it in a box and threw away the key. It's stories like this that show how wars are won and lost not just on the battlefield, but in the minds of leaders and scientists. It's a lesson in history that feels pretty relevant today, doesn't it? If you agree, and you think these stories are important, do me a favor and share this video with one other person you think would appreciate it. It's the best way to help us keep these memories alive for the next generation. So where does the US signal jamming from the title fit into this? While the British were the pioneers of window and the early beam bending, the US turned it into a full-blown symphony of electronic destruction. The MIT Radiation Laboratory, or RadLab, and Harvard Radio Research Laboratory, or RRL, became the free world's headquarters for electronic countermeasures. The US didn't just produce chaff. They produced billions of strips of it. They invented new ways to deploy it, in high-speed cartridges, in bombs designed to explode and release it at the perfect altitude. But they also took active jamming to a level the Germans couldn't comprehend. They built specialized jammer-carrying aircraft. The B-17s and B-24s were fitted with dozens of different powerful jammers, with codenames like Carpet, Mandrel, and Jostle. These jammers were designed to blind every type of German radar. Carpet was a jammer that would automatically sweep across the frequencies used by the Wurzburg gun-laying radars. It filled their screens with so much noise, they couldn't get a lock. Mandrel was a more powerful jammer designed to blind the long-range Freya radars, punching a hole in the Kammhuber line for the bombers to fly through. The US also created dedicated ferret planes. These were fast, modified bombers like the B-24, stripped of their bombs and filled with sensitive radio receivers.
Their only job was to fly ahead of the main bomber stream alone and sniff out new German radar frequencies. It was an incredibly dangerous job.
They were the bait. The moment a German radar locked onto them, their equipment would light up. They'd record the signal's frequency, its pulse rate, its characteristics. Then they'd dive away and race home. That signal data would be analyzed overnight. By the next night, the radio research lab would have developed a new jammer pod, or a new setting for carpet, to counter it. It was a high-stakes, high-speed game of cat and mouse, fought at 20,000 feet, with slide rules and radio waves. This combination of window, the passive simple counter, and active electronic jamming, the brute force American method, was devastating. It crippled the German air defense. It's what allowed the massive 1,000-bomber raids of 1944 and 1945 to fly with survivable losses. It's what blinded the coastal radars on D-Day, making the Germans think the real invasion was coming at Pas-de-Calais, because the Allies had sent a small fleet of boats and planes dropping chaff there to look like a massive invasion fleet. So let's tie it all together, because these two stories are a perfect pair. The Pre-De-Gaussing era, as the title calls it, was the first invisible war. It was the fight against the magnetic mine. It was a defensive battle fought in 1939 to save Britain from starvation. It was won by capturing the enemy's tech, by bravery on a mudflat, and by inventing a brilliant counter, degaussing. The signal jamming era was the second invisible war. It was the offensive battle, fought from 1942 to 1945, to allow the Allies to take the fight to Germany. It was won by stealing the enemy's radar, inventing a simple, brilliant counter, window, and then overwhelming them with industrial-scale electronic warfare. And in both cases, the fatal flaw, the Nazi dismissal, was their undoing. They dismissed the idea that the British could solve the magnetic mine. They were wrong. They dismissed the idea that the Allies could ever create a serious threat from the air, so they buried their own best defense out of pure arrogance. They were wrong again. They believed their technology was supreme. They believed they were the masters of this new invisible battlefield. But technology is only as good as the men who use it, and the leaders who are willing to learn, to adapt, and to face hard truths. The Nazis were blinded not by Allied radar, but by their own hubris. It's a powerful lesson. We often think of that generation, the greatest generation, in terms of their toughness and their sacrifice on the front lines. And rightly so. We should never forget the mud of Normandy or the flak-filled skies over Berlin. But we should also remember the other side of that greatness. The quiet, bespectacled physicists like R.V. Jones, the practical engineers like Charles Goodeve, the quick-thinking women like Joanne Curran, and the brave commandos like Major Frost and Sergeant Cox. They didn't carry rifles. They carried slide rules. They didn't storm beaches. They dismantled bombs in the mud. They fought with equations and soldering irons. And they won a war that no one could see. They proved that true strength isn't just about force. It's about humility. It's about being willing to learn, to adapt, and to accept that your enemy might be just as smart as you are. Or in the case of Window, smart enough to use the very idea you were too arrogant to use yourself. These two stories, degaussing and signal jamming, are the perfect examples of why that generation succeeded. They faced two unbeatable weapons that threatened to end the war before it truly began, and they beat them. They beat one with a complex, invisible electrical shield, and they beat the other with a simple, humble handful of aluminum foil. That's ingenuity. And that's a story we should never, ever forget. If you enjoyed this look into the hidden side of the war, we have many more stories just like it on our channel. You might be interested in our video on the incredible P-51 Mustang, which is right here. And for those of you who have asked how to best support the channel, the simplest way is to subscribe and click the bell. That way you'll never miss one of these stories when it comes out. We appreciate you spending your time with us. Thank you for watching.